Year 10s, welcome back. Today we are doing unions and intersections. So there's heaps of notes for this one. So copy down the notes, pause it when you need to, and then I'll talk. Alrighty. Okay, so a lot of definitions to start with. So a set is a group of elements that can include numbers, letters, or any other objects. So things like, if we said list all the months of the year, the set would involve January, February, March, April. So it can be anything at all. It could be letters, it could be numbers. It might say all the odd numbers under 10 is in the set. So that'd be 1, 3, 5, 7, 9. So a set is a group of elements, and the elements are each one of those things. So January is an element, February is an element. Alright, the sample space we've already talked about is a set of all the possible elements. So the sample space is a list of all the different possibilities that you can get in whatever the trial is. It's also called the universal set, and it's got a funny symbol like a big E, which means universal set, and that can sometimes go on the top bit of the Venn diagram. Venn diagram shows all the elements in a graphical form. So here we've got, that's our Venn diagram, always put a box around it. That is set A, and whatever it's got inside it. And A dash I'll talk about in a minute, but that's called the complement. So that means everything that's not in set A. And here we've got another Venn diagram. We've got set A here, and we've got set B there, and they overlap. So you can see that. We'll talk about that in a few minutes as well. A null or empty set is a set with no elements at all. So remember we use braces and we write all the elements inside the braces there. If it's an empty set, do not write the word nothing or nothing's in here or something like that, because that's wrong. You just literally write the braces with nothing in there. So you leave it empty, or you can use a circle with a line through it. That indicates an empty set, so there's nothing in there. The next one, the complement of an element is all the other values not in that set. So here we've got set A. So whatever they might be there, it might be all the odd numbers under 10. So 1, 3, 5, 7, 9. And if the whole sample space or the whole universal set is all the numbers up to 20, then all the other numbers, not 1, 3, 5, 7, 9, that'd be in the complement of that. So it's all the other values that aren't in that set. And here's another way to think of it. The probability of event A occurring is 0.7. Then the probability of the complement of that event, so it means all the other chances. So if I've got a 0.7 chance of it raining tomorrow, then there must be a 0.3 chance of it not raining. Because both of these events, the actual event and the opposite of the event, so the complement, they must add up to 1, which is certain. So it's like there's no three options. It's just like when there's one option or the other. It's either this or that. They must add up to 1. So I'll give you another example. Richmond, the probability of Richmond win the grand final is 0.8. So the probability that they don't reach the grand final or win the grand final is 0.2, because it's all the other chances. Alrighty, let's move on over here. Now these are extremely important for the next few lessons. The intersection of two sets. So we've got set A, that symbol there means the intersection, and it's the intersection of set B. All elements that belong to both A and B. So if you have a look at our Venn diagram, this section in the middle is the intersection, A intersection B. So this section here is A intersection B. So it's the elements that are in both sets. So for instance, if set A was the people who play tennis, and set B, the people who play basketball. The people who are in the intersection, they're the people that play both tennis and basketball. They're in that section there. So it belongs to both sets, set A and B. So be careful with the wording, set A and B. Alright, the next one, the union. The union, the symbol is A, and then it's a U shape, union B. And that means all elements that belong to either A or B, and that includes the middle bit as well. So we've got here's our Venn diagram, there's set A and there's set B. So anyone, if that was tennis and basketball again, this section here is anyone who plays tennis. In the middle, that's people who play tennis and basketball. And this section here is people who play basketball. So pretty much anyone who plays tennis or basketball or both, they're included in the union. So that's a much bigger section, isn't it, than the intersection. Alrighty, hopefully, and we'll talk more about that in a few minutes. We'll do some examples. And mutually exclusive. That means that two sets, A and B, there are no elements in common. Can you see there's no overlap there? So in this case, the people who play tennis and the people who play basketball, there is no one who plays both because there's no intersection of the two sets. So in this case, maybe they had to pick at school either sport. So, so there's no intersection. So A intersection B it's not zero, but it's a null set. Or you can put the braces with nothing inside it. So there are no elements, no people, in this case, that are in both sets. And a couple more definitions. N of A means the number of elements in set A. So NA means the number of elements. So if it was the months of the year, if A represented the months of the year, N of A would be 12, because there's 12 months of the year. And the probability of A means the probability of set A, of whatever that one occurring. So if it was like, if A was the probability of getting a heads when I toss a coin, the probability would be a half. If it was getting a 3 when I roll a dice, it'd be 1 out of 6 would be my probability. Excellent. See you soon. Hi guys, we're going to do a couple of examples with Venn diagrams. So have a look up here, copy it down carefully, and then we can do it together in a second. Okay, let's have a look here. So the first question says, the sample space is the first 10 positive integers. So hopefully you know what an integer is, it's a whole number. So our sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, our set A is 1, 2, 3, 4, 5, 6. And our set B is just 1, 3, 7, and 8. Okay, so the first question is draw a Venn diagram showing the numbers in each of these sets. So, we can use our universal set symbol there, the funny E shape. I like to do this, and there are 10 numbers in total, so I like to add that at the top. It doesn't say that in the textbook, but I like to do that. Alright, so I'm going to call this set here, set A, and this one here, set B. Alright, so this first circle is set A. So how many do we have in there in total? We have 1, 2, 3, 4, 5, 6. So we've got 6 in that whole circle. And look at B, we've got 1, 2, 3, 4, we've got 4 in that whole circle. But I can't just write 6 there and 4 there, because as you can see, there's a bit of an intersection. So if I have a look at these numbers, I can see 1 and 3 are in both sets. So I like to start with that first, but actually, I like to go, there's 6 in A, so I actually like to write A equals 6 at the top, which means that whole circle. And B is equal to 4 numbers, or 4 elements, because there's 4 in that whole circle. Now I've figured out that there's 1 and 3, so there's 2 numbers that are in both, the intersection. So I like to put a 2 there. And then, see 1 and 3 are already in the middle bit, so then there's still 4 numbers, and I can see that because there's 6 in the whole circle and 2 in that little centre bit there. If you go about B at the moment, there's 2 in the middle bit, so that must mean that there's 4 there. And we call this section here A only, because these 4 numbers are in set A only. These 2 are in set A as well, but they're in A and B. And then the last bit we can work out, there's 7 and 8. So there's 2 numbers there, or there's 4 in that whole circle, and 2 in the middle bit. So there's 2, and that's 2 in B only. So there's 2 numbers that are in B only, and that's 7 and 8, by the way. So there's that. So now we can work out exactly how many numbers we've got. We've got 4, 5, 6, 7, 8. But we've got a problem. We know that there's 10 numbers in total in our set. So you're going to ignore those totals at the moment. So 4 and 2 and 2 makes 8. But there's 10 in total. So where are the other 2 numbers? So let's have a look. We've got 2, 3, 4, 5, 6. Then we've got 7, 8. But where are the numbers 9 and 10? They're not in either set A or B. So that means we put them out here outside the two sets. So that represents A only, A and B, like A intersection B, B only. So there's two numbers that are not in either set A or set B. So we put a 2 outside that box there. That's why it's important to have a box around the Venn diagram like that. So now if we add those numbers up, 1, 2, 3 and 4 numbers, they should add up to 10. Good job. Now that's the most important bit done, the Venn diagram. Now we can answer the questions. List the sets A intersection B. So remember we have to do braces. If you can't draw braces, just draw big squiggly lines. So A intersection B, it says list the sets. So you don't just write the number is 2. Which ones are the intersections? So I can see there's 1 and 3. So 1 and 3 are intersecting. List the sets of A union B. That means everything in A and also everything in B. So in A, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we've also got 7 and 8 in B. So we also write 7 and 8 and close the braces there. That's it. Now the next one, let's find the probability of A. Now you've got to be careful here. The probability of A means the whole circle. So there's 6 chances. If we randomly pick one of these numbers, we've got 6 chances of picking one. And it's out of a total of 10. So our probability of A is 6 over 10. And you can simplify that to 3 over 5. Next one, probability of A intersection B. We can see that there's 2 chances out of 10. So we can write 2 out of 10, which simplifies to 1 over 5. And A union B is 4, 5, 6, 7, 8. 8 out of 10, which simplifies to 4 over 5. And we've just finished that. Good job. And it says here, the last one, are the events of A and B mutually exclusive? Now remember what that means. If they're mutually exclusive, it means they've got nothing in common, no elements in common. We can see here that there's 2 elements in common, so we can say that no, they are not. And if you had to give a reason, you say because there's 2 elements that are common to both sets A and B. If you wanted to list them, you could, and they're 1 and 3. Excellent. Let's do the next question. Okay, so from a class of 30 people, 12 like cricket, 14 like netball, and 6 people like both sports. Draw a Venn diagram of this situation. Alright, so I got a tiny little bit different to the textbook, but trust me, this is a good way. So from a class of 30 people, the first thing I do, the universal set. So it's a symbol that's that funny E shape. It's like the sample space. So there's 30 people. So I know in total, in my whole Venn diagram, there are 30 people. 12 like cricket and 14 like netball. So I'm going to call this one cricket and this one netball. 12 like cricket. So my total for cricket is up there because it's saying 12 like cricket, but that includes the ones that like cricket and netball. So I put the total up the top and 14 like netball. So I put the total up there. That's the whole of netball. And 6 like both. So that's a really good starting point. I can put 6 in the middle there because 6 like both cricket and netball. Excellent. Now that I've done that, just looking at cricket, I'll cover this up. 12 like cricket, but 6 are in the middle. So how many like cricket only? And that'd be 6. 14 like netball, but 6 also like cricket. So 14 minus 6 is 8. So that means 8 people like netball only, and they don't like cricket. So these 8 people like netball only, but not cricket. These 6 like netball and cricket, these 6 like cricket only. Awesome, we're almost done. But we have a problem again. Let's add up these 3 numbers. 6 and 6 is 12, 12 and 8 is 20. But we have 30 people in our class. So 20 people are involved in these sports. Where are the other 10? So the other 10 are outside both these sets. They're the ones that like reading books and stuff like that. So they are not playing cricket or netball. So there's 10 people outside those 2 elements there. And now if you add these 4 numbers up there, those 4 numbers add up to 30, which is a universal set. Excellent. Now we answer the questions. That's the hard bit done. It's just like a puzzle, really. Number who like netball only. So remember what I said, netball only. There's 14 that like netball, but netball only is 8. And so we just write 8. There's 8 people like netball only. Now, how many like neither sport? Remember we talked about that? There's 10 people there that like neither sport. So it's 10. Now the next ones, see these are numbers, the number of people. The next ones are probabilities. So, what's the probability that someone likes netball? Now you've got to be careful with the wording again. It just says netball, it doesn't say netball only. So how many people like netball? There's 14 people like netball. So there's 14 people out of how many? And it's over the total, which is 30. And we can simplify that to 7 on 15. Next one, probability who like netball only. So that's 8. 8 over 30, which is 4 over 15, simplified. Now the next bit, probability they like both sports. So how many like both sports? There's 6 people in the middle there that like cricket and netball. So there's 6 people. And I've written down here, that's actually asking for the intersection. So it's C, intersection N. That's the symbols for that, if it asks you that way. So there's 6 people out of 30, and that can simplify it to 3 over 15. Another way of asking that question, they might say a worded question, they might say, if a child from this class was picked at random, what's the probability that they would like both sports? So out of the 30 people, there's 6 of them that like both sports, so you've got 6 chances out of the 30 in total. And I put another one on, probability who like either sport. And that's C, union N. So that includes these people, those 6 who like cricket only, and the 6 that like cricket and netball, and the 8 that like netball only. So we add those up together, and there's 20 kids there that like either sport. So it's 20 out of 30, which simplifies to 2/3. So that's a typical test question you'll get, so make sure you understand both of those questions. We've got another example in just a second. Hi guys, one more example here. So I want you to copy down this, so it's all ready, and then when I explain it, we can just fill it in together. Alright, okay, so now we have to learn about a two-way table. So it's just an extension, or basically, here's our information in a Venn diagram. We're just going to put it into a table format. So let's have a look at this. We've got a question, and set A, we've got 2, 1, and then set B, and we've got 6 there, and we've got 3 in neither set A or B. So remember all the wording. So A only, there's 2. A intersection B, there's 1. B only, there's 6. The union means A union B means 2 plus 1 plus 6, so that's 9. 3 is in neither set, and okay, that's pretty much it. So the first thing we need to do is work out, I like to do this, the book doesn't do it, but the universal set. How many in total? So there's 2 and 1 is 3, and 6 is 9, and 3 is 12. So I put my E symbol up there, the universal set is 12. So I know that we've got 12 in our total, our sample space for the universal set. Alrighty. Now, our two-way table. We draw it up like this every time. They're always the same. There's event A, and that's the complement of event A. Then there's event B, and the complement of event B. So all you have to do is look, and these are all intersections. So here, this one here, A intersects with B. So we have a look here. Where does A intersect B? There's 1. So we put down a number 1 there. Alright, so this spot here, it's A intersecting with B dash. Okay, so how do we fill that in? So what is B dash? B is the complement of B. So there's B, the complement of B is everything else. So if we shade it all in, we've got the 3 here, I'll shade it in for you. So B dash is that whole section there. Okay, and where does it intersect with A? So we've got that whole bit shaded in except for B, and then it intersects with A. A is here, this one here. So it's only that value there, which is 2. And then we can work out the total there. The total of A is 2 plus 1. So I like to put them there as totals anyway, so that's 3. But you can see that A intersecting with B not is 2 anyway. Alright, and I put the total here is 6 and 1, which is 7. Sorry, now I've sort of coloured in that chart already, but anyway. So B intersecting with not A, or the complement of A. So the complement of A is everything around here that's not in A. So I'll cover that up. And where does it intersect with B? There's B, so it's just this one here. So it's 6. So if you want to think of it, I'm just trying to explain how I got that, but it's just that value there. Now here, A, we call that A naught, by the way, the complement. It's A naught and B naught. So which one's not in A and not in B? So there's only one here, which is 3. And we can add all the totals up if you want. What's the total of B? See there's B. What's the total of B goes across here. The total of B, I've got it up there anyway, is 7. And the total of A is 3. Can you see that? And then I can add these two up as well. So that's 9, and that one's 5. And our grand total should be down here. So 3 plus 9 is 12, but it also works this way. 7 plus 5 is 12, which is our grand total up there. So if you can get those numbers to work, then you know you've got your two-way table correct. If you don't, then you've made a mistake. Alrighty, now we've just got a whole bunch of questions we have to answer based on that two-way table. So, and you can use either the number in A intersection B. So we can either look here, which is 1, or A intersection B is 1. So it's the same answer, so we've got 1. Now for these, I just use our two-way table. The number in A naught intersecting with B. A naught intersecting with B is 6. A intersecting with B naught. A, B naught is 2. A naught intersecting with B naught, or the complements, which is 3. And that's really asking how many people are not in either set. So it's 3, are in neither set. Now, the number in A means the complete number. So the number in A in total is 3. And this here, we look at it down there on the two-way table. The total is 3. The number in B naught. So what you have to do here is look in B naught, or the complement of B, and look at the total. The total there is 5. So the two-way table's pretty easy to answer those questions. Now the number in A union B. So remember, for this one, I'm just going to look up from here. We've got 2 plus 1 is 3, plus 6 is 9. And there we have it. So we've answered all those just from our two-way table and our Venn diagram. Now we've got a couple of probability questions. The probability of A intersecting with B. So you can, to find the number, it says here it's 1, or we can look at our Venn diagram over there. So we've got 1 out of 12 in total, because 12's our universal set. Probability of A naught, or the complement of A. So again, we can just look, no, we didn't have it here. So A naught is, the total here is 9. So there's 9 altogether. And another way to do it, if you wanted to do it from the Venn diagram, A's in this circle, the complement of A means everything other than that circle. So we've got a 6 there, and we've got a 3 there, so that's 9. So we've got 9 out of 12, which is 3/4 when we simplify it. And the last one, the probability of A intersecting B naught. And here we've got the number, A intersecting B naught is 2. Again, it's 2 out of 12, which is 1 out of 6. Excellent, guys, we are done. You should do exercise 8B now. Questions from the course outline, and I will see you soon.